Okay, this figure is based on the Pythagorean theorem. Squares have been drawn on the sides of a right triangle, given that A equals 8. So I'm going to write that in. The side length is 8. C equals 17. All right. Find the area of square A. All right. So this is a right triangle with squares built on each of its sides. And remember that we said that the square of the hypotenuse is equal to the sum of the squares on the other two sides. So the area of square A, well, square A has a side length of 8, so that would just be 8 squared, which is 64 units squared. All right, the area of square C, all right, you can see square C here. And it has a side length of 17, so that would be 17 squared, which is 289. And let's write these areas in the squares here. 89, 64. The area of square B. All right, to find square B, there's several ways you can do it. The fastest, simplest way is to remember that this square plus this square, their areas, have to add up the area of this one. And knowing that, then, we can go work backwards. 289 minus 64 equals the area of square B, because square A and B have to add up to 289. So 289 minus 64 gives us 225. All right, so this area is 225 units squared. All right, and then so what is side B? Side length of B. Do you all know that if you happen to have the area of a square and you want to know one of its side lengths, all you need to do is square root it. Because remember, squaring and square rooting undo each other. And so if I find the square root of 225, that's 15. They are inverse operations. Think about how you get the area of a square. How do we get the area of the square A? We took a side length and squared it. Square C, we took a side length and we squared it. All right, so what undoes squaring? Square rooting. So if we know the area is 225, that's what we do. So remember, this square here plus this square here has to equal that square. And that's what this is all based on. So we know the areas of 2 of the 3 squares, we can find the area of the third one. In this case, we're missing one of the smaller squares, so we subtract to find it. All right, that's all I think we need to say about this one.